India runs on imported crude oil. Every price spike in the global market directly hits the national budget, making the country's energy security highly vulnerable to external shocks. To cut this reliance, the government mapped out an aggressive transition. Through a mandate from Niti Aayog, the goal was set to replace 20% of standard petrol with ethanol nationwide by 2025, creating a blend known as E20. The rollout met immediate resistance. Across social media, posts went viral, claiming this new fuel mixture was corroding fuel lines, tearing apart engines, and slashing fuel efficiency by up to 50%. These claims quickly moved from online forums to political podiums. State leaders and opposition politicians began citing the rumors, publicly warning motorists that they were being subjected to a massive, untested experiment. The panic reached its peak when a public interest litigation was filed directly with the Supreme Court. The petition demanded a complete halt to the blending program, citing widespread material degradation and severe safety hazards for everyday drivers. We need to look at the engineering data to see if the government is genuinely damaging millions of engines, or if the public is misinterpreting the physical realities of a massive energy transition. Running cars on alcohol is an old engineering standard. When Henry Ford designed the original Model T, he specifically engineered it with the capability to run on ethanol. But it was the global oil shocks of the 1970s that pushed governments to take the fuel seriously. As crude supplies tightened and lines at gas stations stretched for blocks, nations needed an alternative fuel they could grow domestically at scale. Brazil launched its pro-alcohol program in 1975, subsidizing the sugar industry to produce fuel. Within a few years, they achieved widespread national ethanol adoption, eventually leading to a modern fleet where nearly every car can run on pure ethanol today. The United States and the European Union followed suit, establishing their own renewable fuel standards. Today, an E10 blend, 10% ethanol, is the standard pump gas across most of the US and the UK. Major economies have successfully powered their transport networks with ethanol blends for decades without destroying their vehicles. The friction India is experiencing right now comes from the sudden nationwide mechanical adaptations required to catch up. To understand how this fuel behaves in an engine, we have to look at its chemical structure. Ethanol is a simple alcohol, C2H5OH. By weight, about 35% of that molecule is pure oxygen. Having oxygen built directly into the fuel forces a highly efficient complete combustion process inside the cylinder. This chemical reaction drops carbon monoxide tailpipe emissions by up to 30% and significantly cuts down on particulate matter. This chart shows the lower heating value, the actual energy density of both liquids. A single kilogram of pure ethanol simply holds less potential energy than a kilogram of pure petrol. When you replace 20% of that high-energy petrol with lower-energy ethanol, the total energy output of the resulting mixture drops. In controlled tests, this physics equation translates to an exact 2 to 6% reduction in fuel efficiency. Automotive Research Association of India testing confirms this range. The viral social media claims stating drivers are losing 20 to 50% of their mileage have no basis in the physical limits. You will get slightly fewer kilometers to the liter because the fuel contains slightly less energy. That is a strict law of thermodynamics. But the apocalyptic numbers driving the public panic are mathematically impossible. Researchers at IIT Kanpur have run extensive endurance tests on the new fuel. Their conclusion is absolute. For modern, BS6 compliant vehicles, E20 causes zero internal engine damage. The real mechanical threat comes from a different chemical property. Ethanol is hygroscopic. It actively pulls moisture out of the surrounding air. Over time, this water separates from the fuel and pools at the bottom of the gas tank. In a modern car, the fuel system is built with stainless steel and specialized polymers to resist this moisture. But in older, pre-BS4 vehicles, that pooled water acts as a solvent, degrading non-compatible rubber seals, cracking fuel hoses, and corroding metal lines. There is also a secondary chemical byproduct. While standard tailpipe pollutants decrease, combusting ethanol triggers a sharp spike in toxic aldehyde emissions, specifically acetaldehyde, which irritates the respiratory system. Modern engineering handles ethanol effortlessly, but retrofitting this mandate onto millions of older vehicles creates a hidden maintenance tax for drivers, while introducing complex new chemical byproducts into city air. Replacing 20% of the nation's petrol requires a massive volume of ethanol, and the government's primary motivation is economic. By growing fuel domestically, India avoids spending an estimated 30,000 crore rupees every year on imported crude oil. That massive block of capital is redirected directly into the local economy. It guarantees a stable, high-demand market for the agricultural sector, turning surplus sugarcane into a reliable cash flow for farmers and sugar mills. Sugarcane alone cannot meet the 20% target. To feed the skyrocketing demand from distilleries, the industry has rapidly pivoted to grain-based ethanol, driving nearly a 9% annual growth in maize production. This chart illustrates the severe resource cost of that agricultural boom. To produce just 1 single liter of sugarcane ethanol, the crops require approximately 2,860 liters of irrigation water. To keep the pumps flowing, between 7 and 8 million hectares of arable cropland must be diverted entirely away from food production. The ethanol program trades external reliance on foreign oil for an intense internal strain on the country's groundwater and agricultural land. It is a direct competition between powering vehicles and feeding a massive population. Because of those severe limitations on land and water, both Niti Aayog and the International Energy Agency acknowledge that ethanol can never completely replace petroleum. It is being heavily deployed right now because of its speed. Electric vehicles require decades to build out new charging grids and battery supply chains. Ethanol flows immediately through the millions of gas stations and combustion engines that already exist today. It functions purely as a transitional technology, a placeholder that provides immediate decarbonization benefits using the infrastructure we currently have. Ethanol-blended petrol is a calculated compromise. We accept lower fuel efficiency, upgrading older cars, and straining agricultural resources today to buy the time needed to build the zero-emission networks of tomorrow.